What is the world made of? If we look at a pen and a notebook, we observe that they are made up of different materials. They have different properties and different uses. Hello everyone, welcome to the Oliveboard platform. My name is Antara Bhuyan, and as you know that we are discussing science. From class 6 we have started our journey. Eventually, we will discuss 7th, 8th, 9th and 10th books as well. So please consider subscribing to the channel. For the previous chapters from chapter number 1 to chapter number 5, you can refer to the playlist. In this lesson, we are going to discuss chapter number 6, which is materials around us. So have you ever had tea in a mud pot or in a mud cup? It is made up of mud, clay, etc. This is not something new. If we look into ancient India, there was the Harappa civilization, and there also terracotta pots were used. From somewhere around 7,000 to 8,000 years ago from present times, if we talk about the 4000 BCE, then we see that even at that time also people were using terracotta which were made of wheels. There were also handmade pottery as well. They were used for decorative items, for protective items, etc. So that was the time of Harappa civilization, and today is the modern India of the time of say 2025. We're about to enter 26. So if we consider 2026 here, it will be more than 2025 years ago. And if we consider again 2600 years from this margin, then that will again be 2500 years ago. So it's more than say 4500 years back we are talking about. So even at that time, people used to use the terracotta, which was nothing but the baked clay pots, and so much so that from different sites at the time of excavation, even in present times, they have been discovered. So if you ever get a chance to visit the National Museum in New Delhi, then you can see that these preserved items are still stored there. At that time, probably they were used for storing grains, food, etc. Now, as we observe further, then we see that if we consider a spoon, it is made up of say steel, a glass made up of steel, a ball made up of different items, bat made up of the willow wood, notebook made up of paper, then the paper is taken from wood again, a plastic scale, or say different items which are made up of different materials. But what do you observe common in all of them? We can see that we cannot use a cloth for storing water. In fact, I know about a story where in village, after taking some intoxicated elements, people used to go and do try such kind of things, that they take up some sheathed vessels and they try to fill water. No normal person will try to do that. And if you even try, it will not hold water, right? Because a cloth is made up of different material. Similarly, if we look into a tennis ball, a cricket ball, a hand exercising ball, they are different in their properties. A cricket ball will be, say, the hardest among them. Then a tennis ball will be comparatively softer. And then if we talk about the hand exercise ball, it will be even more softer than the previous two. But this is not the hardest element in nature, and this is not the softest element that we have seen. So this hardness and softness, it varies. So we have to know more properties about them. So what are these objects made up of? If we consider a notebook, it is made up of paper. If we consider a plastic chair, it is made up of plastic. If we consider a wooden chair, it is made up of wood. If we consider glass, which is made up of glass, right, silicates, in that case, it will be say transparent or translucent. And if we look into a steel glass, that will use some kind of a metal, that is steel. And if we look at cloth, it can also be made up of different items like cotton, silk, wool, nylon, polyester, etc. So we understand that there are so many materials, and to study them, we have to do some classification. Just like we do classification of books, we arrange our books in a sequence or based on the category, say history, then geography, science, we keep them separately in a library. If we look into our kitchen, there also we arrange the things based on their use or based on their material. Say, for example, in this row, there are the wheat and say pasta and macaroni, etc. Here we have the spices. So, based on the use, it is categorized and kept like that, which can be termed as classification. So, how do materials look? These materials have made up the items that we use in our day-to-day life, but how do they appear? Say, for example, if we talk about the metals will be lustrous. That means the metals will have a shiny surface. Most of the times they're polished and used, and they will appear to be shiny. For example, iron, copper, aluminium, gold, they all have luster. That is, that shiny element that it has. But again, as it is commonly said, all that shines is not gold. Now, luster can fade over time due to the air and moisture, so much so that iron can even rust, and rusting of iron can happen. Whereas if we talk about gold, it is very stable and we don't find rusting in case of gold. Silver being just below gold, so it will be oxidized and it will appear to be dark over a period of time. So like that, different materials have different kinds of luster, and based on their stability, they will show different kind of reactions over a period of time. If we consider the non-lustrous materials, they are non-shiny. Say, for example, paper, wood, rubber, jute, all these are non-lustrous. They do not have a shiny top or they do not shine in general. Now, how does a material feel with respect to hardness and softness? As we had discussed in the tennis ball, cricket ball, and an exercise ball, we see that some materials are difficult to compress or stretch. If we see a cricket ball, we are not able to compress a cricket ball. Can we compress a stone, iron, a clay made baked brick? Then all these materials are hard and they cannot be compressed. If we look into an eraser, candle, sponge, chalk, these are comparatively softer. And as soon as I use the word comparative, that means it's relative. Hardness is not absolute. For instance, rubber is harder than sponge, but it's much softer than iron. So these are comparative properties. Now, if we look into this diagram, we observe that a group of children, they're playing hide and seek. Some people, they have chosen this glass behind which she is hiding. Some has chosen this window to hide, some has chosen the tree to hide, and so on and so forth. Now, all of these materials can be classified as transparent, translucent, and opaque. Starting with transparent, if light can pass through some material and if the material is clear, then what we see from this end is clearly visible from this end as well, right? Say, for example, glass, water, air, cellophane paper, sorry, all these are transparent materials or they are see-through. Say, for example, windows. If we look into opaque material, they will be non see through or they won't be transparent. Light cannot pass through them, and as a result of which, we cannot see this side to that side and vice versa. We cannot see through them. Say, for example, if we talk about wood, then wood is a wood is opaque. So through opaque material, we will not be able to see. For example, wood, cardboard, metals, they are opaque material and light will not pass through them. Now, if we talk about the translucent material, in this case, yes, we can see through, but not clearly. If you look into a shaded door or a shaded window for that matter also, then light will not clearly pass through it. It will have some diversions, some refractions, as a result of which we will see that it will appear frosted. The visibility will not be very clear. Now, in the other cases also, the reflections and refraction properties of light will be there, but it will be different for different materials. So if we take frosted glass, butter paper, colored window vanes, in that case, again, it depends on the color. If it is a thin coat of some light color, then probably it could be seen. And if it is a dark coat of some color, then probably we will not be able to see. So materials will be categorized as transparent, opaque, and translucent based on this see-through property. Or we can say how light passes through them. Now, how does some materials they disappear in water? If we look into shikanji, which is nothing but a mixture of salt and water, then there can be some lime also, etc. Then we eventually note that it will be soluble in the water. So what is this property of solubility? It is that the material will completely dissolve in the water. For example, sugar and salt, this will completely dissolve in the water. Now, even if we talk about the water color, in that case, the color might be different, but it has mixed through properly. So that's soluble. What is insoluble? Insoluble, that means, say for example, sand. The sand and the water will never mix. The sand will deposit on the bottom of the glass and it will never mix up with the water. By simply doing decantation or by simply removing that glass of water into a separate vessel, all we will be left out with is the sand. So that is known as insoluble materials that do not mix with water. But have you ever wondered what happens to the fish who lives in water? They have oxygen, and this oxygen, which is soluble in water, it helps the fish to breathe, and that applies to all other marine lives or freshwater animals and plants and say fishes, etc. All the flora and fauna which live in aquatic environment, they can survive because there is oxygen dissolved in the water. Now, what is ORS? ORS is oral rehydration solution. If somebody suffers from diarrhea, some illness, or is simply tired, then they can use the ready-made ORS packets which are available in the market, and many of them also have additional sugar which are ORS juices and not plain ORS, right? So in that case, what can be done is ORS can be prepared at home by mixing 6 tablespoons of sugar and half a tablespoon of common salt in 1 liter of boiled and then cooled water. This is the simple ORS which can be taken in case of any kind of illness or even weakness for that matter, or say diarrhea, etc. Even in case of dengue, etc., this rehydration helps a lot. Now, if we look into some liquids like oil, vinegar, honey, do they dissolve in water? We can see that oil will never dissolve in water, whereas vinegar and honey will dissolve in water. Now, what are the properties of these materials that we have? They must have some properties. Say, for example, for a human, we say, okay, this particular human is tall, this particular human is short, that is the property of that human. Or this human is smart, this human does not study, that is also a property. So similarly, Why was I not able to transfer water from the jug into an empty bottle? Because this jug will hold different amount of water and say this bottle will hold different amount of water. What is this known as? We use the term volume. It is known as volume. If we have a water bottle of 500 ml, that means the volume of that water bottle is 500 ml. Similarly, most of the times it is denoted in the bottle itself that what is the capacity of the bottle. That is how much quantity of, say, fluid, milk, water that particular bottle can hold. So what are these? These are properties of materials. We have seen some properties like luster and hardness previously. Now, if we look into what is the universal clue to find out, there are two things. One is mass and another is volume. So, how heavy a material is mass. In later classes, we'll have better definitions. And how much capacity it has, how much space it has, it is known as the volume. So what is mass? Mass is the amount of matter in an object. That brings us to another word, that is matter. So understanding mass and volume further, if we go to any shop and want to get, say, rice or dal, we have to ask for, say, 1 kilo or 1 kg of rice. In that case, the shopkeeper will take out his measuring cup or the measuring vessel and he will measure in the weighing scale and he will give it to us. If you weigh 3 identical cups filled with water, sand, pebbles, you will find they have different weights. Why? Because some are heavier and have more mass. That is, if we take, say, 1 kg of rice, then probably 1 kg of rice will take up more space or more mass. And if we take a stone of 1 kg, it will take up less space. So if identical objects are used, say this glass will hold more rice and will hold just one stone and will hold again one glass of sand. And if we weigh them, if we measure them, then it will be different. So we measure mass in kgs and grams. Kg is the short form of kilogram and then gram is the shorter quantity. 1 kg equals to 1000 gram. Now coming to volume. Volume is the amount of space an object occupied. So when we say this is the space being occupied, we mean that this is the volume. When students put their bags in their chairs, they can't sit down. Why? Because the bag has taken up the space. This is nothing but the space in the bag's volume. The bigger the bag, the bigger place it will occupy from the chair. In case of liquids, say for example, the milkman, he comes with the vessel for measuring the milk and that looks different and that one has different sizes also, 500 ml, 1 liter, like that. So we measure liquids in liters and milliliters. Now, this kilogram is the universal or international unit of mass. And what is the international system of units or SI unit of kilogram of mass? It is kilogram. Kilogram is the SI unit of mass. Now, when we write kg in lowercase or in small letters, we mean it is the symbol for kilogram. Now, if we write 7 kgs, it will mean that 7 kilogram. Similarly, liter and milliliter are used for liquids. Okay. And for volume, we use meter cube or kilometer cube. But again, if we talk about the SI unit, then in that case, the SI unit for volume is cubic meter. That is, we will write it as meter cube. So like this, we can understand about the different perspectives or properties. 1 meter cube is equals to 1000 liter. Now coming to matter, when we have already talked about mass and volume, we can give the definition of matter. So what is matter? Anything that has mass and occupies space is known as volume. And by now we know that occupying space, say in this rice bag, it is nothing but it is volume. So again, anything that has mass and occupies space is known as matter. Now, everything around us that we see, it is nothing but matter. The air that we breathe, even that has mass and occupies space. Though we cannot see with our naked eye, but we can feel air in different cases. So that is why we know that air that we breathe is also matter. Now, if we do a quick recap, then we have seen that matter, the fundamental stuff that has mass and volume. If we talk about material, then there are different material or they are the specific type of matter. Say for example, they can be metals, they can be non-metals. They have different properties like metals have luster. We will in future study about ductility, malleability, etc. And non-metals, for example, wood, glass, plastic, etc., they will not have the property of luster. Then we have also seen that they have different properties based on how light passes through them and how objects are visible to us. It can be opaque, transparent, and translucent. So the things we create around us, everything that is around us, they are nothing but matter. This is not something new. Even in ancient time also, there used to be somewhere around 20 fundamental gulas based on which these properties were denoted. Now, I am going to share what I know in my language, and you can tell me what is used even at present times in different other languages. As you can see, guru is used for heavy, even now also. Manda is for business, manda hai. That means it's slow. That means the business is running slow this time. Hima means cold. And similarly, say mridu is for soft. Then laghu ahar, laghu bhojan is for light in weight. Ushna is for hot. Ruksha, dry skin, that is ruksha. Then khara sona, that is for rough. Khala is for moving and unstable. So what are the words out of these that you know from, say, previously itself, or it is used even now as well, that you tell me in the comment box. So that's all for this particular lesson. We have done chapter number 6, materials around us, and somehow I find that the initial chapters are and easy to go, but if you see the lessons which are coming in the future, then they will give us more insights and more detailings even in class 6. So that is why I have started this NCERT series. So please stay tuned and subscribe for more. Thank you. Take care. Stay blessed. Bye bye.